Okay, so question 8. Question 8 asks how the object is moving during a gravitational field in an upwards and downwards direction. For this problem, we use the equation work equals the force times displacement equals positive mg4. Okay, so by looking at the question, we can see that the total displacement for A is 4. Since 4 is positive, as well as the work and the displacement in the equation, okay, so since m is positive, and the g and the 4 is all positive, this means our work is going to be positive. If our work is positive, then our kinetic energy is also going to be positive, meaning we can follow our equation and we can go ahead and proceed with the equation. We can plug in the values in and solve as shown above. And once we do that, we get that the velocity will be 9 meters per second for part B. For part C, it is asking us to generate the equation for any y. And we can go ahead and find that. It's going to be mg delta y equals half of m v final squared. So v final squared is going to be 2g times delta y, and because delta y has to be positive, our final is going to be v equals the square root of 2g delta y. So part D is asking us to find the potential energy associated with the force. We know our direction of the displacement is going to be going downwards. And if we go down, we know the work is going to be positive. And we know that going downwards, that y1 is greater than y2. So we know that y1 minus y2 is going to be positive and greater than 0. So the equation we would use would be the work equation, W equals mg times y1 minus y2, equal to the potential energy of y1 minus the potential energy of y2. Knowing all of this, we can conclude that the u of y1 is going to be equal to mg of y1, and the u of y2 is going to be equal to the mg of y2. And therefore, if we go ahead and subtract them, we know our equation will end up being uy equals mgy. For E, it's asking us if we are going upwards. And to calculate the mechanical energy, we know that the mechanical energy is going to be the sum of the kinetic energy and the potential energy. Therefore, we can conclude that we would use the equation 1/2 mv1 squared plus mgyf is equal to half of mv1 plus mgy initial.